Okay, so today what we're going to do is verify these trig identities. So it's actually going to show you what you're going to simplify it to. And there's some techniques or hints for verifying identities. Now, when we verify these identities, it's going to have an equal sign. So you're going to look for the more complicated side of the question. And that's the side that you're going to simplify. And you're going to work towards simplifying either the left side or the right side to make it equal the other side. All of the examples in my notes today, I've set up all my problems so that the more complicated side is on the left. And I'm going to make all of my left sides simplify down to the right side. So essentially what I'm doing is the homework that you've done prior to today is I'm giving you the answer to the problem and you have to show me how you got there. So then after we figure out which side to simplify, and it may not always be the left side, that's just how I set up my problems today. My techniques are going to be either to change everything to sine and cosine, which were actually the instructions in the 7-1 homework. They told you to change everything to sines and cosines. So this is one of the techniques. Another technique would be to find a common denominator. And another technique would be to substitute in a Pythagorean identity, or even a quotient identity, or a reciprocal identity. The last technique here called, that says conjugate, is I'm going to be multiplying my fraction by its conjugate. And remember, the conjugate is just the opposite side of what's in the problem. Once we multiply something by its conjugate, we should be getting a Pythagorean identity or some form of one. And then that will help us simplify our problem. Next slide is just a screenshot of what I just said from your textbook. So it's the screenshot, the explanation of what I just said for those 5 steps. So you can read through it. The next slide, caution. Now, all of the questions today are going to be equations. And some of them are going to look like 2 fractions set equal to each other. My caution here is do not cross multiply. Do not solve these like a proportion. We are not solving for anything. What we're doing here is like similar to a geometry proof. So what you're going to have, in geometry we had statements and reasons, but what we're going to have here is going to be your left side of your equation, and then you're going to have a right side. You're going to choose one of them. Today, I'm choosing the left, and I am going to simplify my left, and I'm going to make it equal the right. So I'm going to show all of the work, and then I'm going to make it equal whatever was on the right side. So it's like a proof. Again, do not solve it as if it is a proportion. So let's get right into solving, or saying. So again, same thing we've been doing, but now I've already told you the answer. So I'm going to simplify the left side and make it simplified down so it equals sine x. So the technique I'm going to do to simplify this one down is the technique that said change everything into sines and cosines. So what I'm going to do is I'm going to change the tangent, and I'm going to change it into sine over cosine, and I'm going to change secant to its reciprocal. So for my numerator, tangent now becomes sine x over cosine x. My denominator, that secant, that's the reciprocal of cosine. I need to realize that this fraction bar, the black bar here, this means division. So really what I'm doing here is sine x over cosine x divided by 1 over cosine x. Remember, when we divide fractions, we do a keep, flip, change or a stay, change, change. So I leave the numerator the same, and I flip this to the reciprocal. Notice my cosines cancel, and now I'm left with sine x, which, if you look back at the beginning, bring this down now, your goal was to make it equal to sine x, which is what I did. So your answer on the quiz is going to be all of this work, and it has to flow logically. If it does not make sense logically, you're going to get it wrong. For the next one, I'm going to use the technique of substituting in an identity. So if you remember or memorize your Pythagorean identities, which you need to, I'm going to be using the identity that tangent squared x plus 1 equals secant squared x. So I am going to replace my numerator with what the Pythagorean identity tells me it equals. So my new numerator is now going to become secant squared x. Going to rewrite the denominator, and now I need to simplify that fraction. So I could take one of the secants out of the top and get rid of the denominator. So this simplifies now to secant x. What I was trying to make it equal was secant x, so I just verified this identity. Sort of think of it as when I simplified the red and the blue, think of it as being like x squared over x, and this simplifies to an x. Take away one of the exponents, and it's that simple algebra skill. Example, I could actually do two different ways. So I'm going to do it the simpler way first, and I'm going to replace what's in the parentheses with an identity. So again, the Pythagorean identity that I'm using is going to be 1 plus cotangent squared x equals cosecant squared x. So I'm going to replace what's in the parentheses with this identity. So I'm going to leave the sine squared x outside. And now in the parentheses, I'm putting cosecant squared x. I'm now going to change cosecant into its reciprocal, which is sine. So I'm going to change this into 1 over sine squared x. Going to just rewrite the sine squared x, rewrite that straight down. If you want to put a 1 underneath it, notice it simplifies diagonally. These become 1s. So now I'm left with 1 times 1 over 1 times 1, and this simplifies to 1, which is what I was trying to make it equal. Now, you could also have distributed the sine squared x. Keep in mind that there's multiple ways to verify these identities. So you could have also done number 3 by distributing. So just to show you a different technique, and neither one is incorrect. They're both going to be correct techniques. The one that I showed you first, though, is the simpler way. So I could have also distributed the sine squared x to the 1 and the sine squared x to the cotangent. So this becomes sine squared x, and then I'll distribute this one in blue. So sine squared x times cotangent squared x. And now I need to change the cotangent into sines and cosines. So I'm going to change just this part into cosine squared x over sine squared x. Let me rewrite this down. I can drop down my red. And notice this simplifies. And now I have sine squared x plus cosine squared x. And remember, this is another identity. And that identity is sine squared x plus cosine squared x equals 1. So now I'm going to change this to a 1. And notice that's what I was trying to make it equal. So just to show you, the other way I did it a lot faster. But again, there's nothing wrong with this method either. So again, these are going to be trial and error. You're going to have to look, you're going to have to analyze, you're going to have to say, okay, do I have any identities to start off with? Do I have a bunch of reciprocals that I could maybe change everything into sines and cosines? Do I have fractions? Maybe I need to find a common denominator. And then another new technique we're going to learn today is multiplying by the conjugate. And that will be another way that you can simplify down your identities. So again, my more complicated side is the left side. So again, I'm going to apply my commutative property here, and I'm going to flip-flop these two terms. So I'm going to rewrite sine squared x, and then I'm going to switch the place of cosine squared x, and then I'll switch tangent squared x. Now, you really don't need to show me this. If you wanted to just show me that this and this together become a 1, that was my goal here, to get these two side by side, and now this simplifies to a 1. I'm going to drop down my plus tangent squared x. And notice again, I've got another identity, and 1 plus tangent squared x equals secant squared x, which is what I was trying to prove. For this particular problem, I used two Pythagorean identities. I used sine squared x plus cosine squared x equals 1, and then I used the 1 plus tangent squared x equals secant squared x. Those were the two identities that I used, and then I used substitution. Again, I'm trying to get my fraction here into two separate terms. So notice my numerator, again, I'm going to use an identity. So again, the identity that I'm using is sine squared x plus cosine squared x equals 1. I'm going to solve this identity for sine. So I'm going to move the cosine over. And I get sine squared x equals 1 minus cosine squared x. Realize that you're trying to get two terms here. So by replacing that numerator with what sine squared x equals, I now have a new numerator of 1 minus cosine squared x. My denominator of cosine is still the same. And now what I'm going to do is pull it apart. And I'm going to give each one of the terms in my numerator its own cosine x denominator. So I'm sort of undoing like a common denominator. So I'm going to put 1 over cosine x, and then I'll do the cosine squared x and give it its own cosine x. Now, always think about glancing back over at your right side and say, okay, wait a minute, what was my goal? What am I trying to make it become? And then notice that the black, the 1 over cosine x, that's the reciprocal of secant. And then the red, I can just simplify the fraction, and I can get rid of the cosine in the bottom, and then the exponent in the top. So then it's 1, so it's just cosine x. So what I was trying to get it to is what I just got. So secant x minus cosine x equals secant x minus cosine x. So I did verify it. For my next example, I'm trying to make it equal a 1. So I'm going to pull this thing apart. So I'm going to treat my numerator as if it were cosine x times 1. So I'm going to do cosine x, and put a sine x underneath that one. And then over here, I'm going to put cotangent underneath a 1. Now, I'll show you another way where we're going to change them all into sines and cosines. But this is one method that you can do. And then remember that here I'm multiplying. So now I also still need to change cotangent. And cotangent, I'm going to use my quotient identity. And this is going to become cosine x over sine x. I still have this one. Now I'm going to flip this fraction. So the red, when I do 1 divided by cosine x sine x, flip it to the reciprocal. So the red really now becomes, this is the same, and then the red becomes sine x over cosine x. When I go to multiply this fraction, everything becomes 1s. So I got what I was trying to prove. I was trying to get 1 equals 1, bring down that 1, and it's verified. Now, I'll show you a different way that you could have done this one, just to give you options here. So another way that we could have done this same problem is, again, cosine x. Let me do it in black. Cosine x over sine x cotangent x. What I'm going to do here is, instead of pulling apart, I'm going to change this into the quotient identity. So cosine x and then sine x, and now I'm going to replace cotangent with cosine x over sine x. And then now what I'm going to do is I'm going to simplify that denominator. And then now it just becomes cosine x over cosine x. Anything divided by itself is 1. And that's what I was trying to verify it to. So that way is a lot simpler. But again, keep in mind you've got options here. All right, so for example 7, I'm going to use that last hint, which was multiply by the conjugate. Remember, a conjugate, we change the sign. So here what I'm going to do is I'm going to multiply both the numerator and the denominator by secant x plus tangent x. Because again, remember, whenever I multiply by the same thing over the same thing, it's essentially multiplying it by a 1, but it does change it. Now, when I multiply something by its conjugate, I really don't need to do the whole FOIL process. All I need to do is first and last. Because in my FOIL word, outer and inner, when I do the whole thing, cancel out. Because outer will give me negative secant x tan x. Inside would give me positive secant x tan x. So the outer and the inner always cancel when you multiply by a conjugate. So really all you need to do are the first two and the last two. For the numerator, I'm just going to multiply secant x plus tan x by 1. So my new numerator is secant x plus tangent x. But my new denominator, after I do first, I get secant squared x, and last gives me tangent squared x. When you use this conjugate technique, your goal is to get an identity out of it. So my denominator is a Pythagorean identity. It's a form of it, and let me show you what it becomes. So if I take the Pythagorean identity of 1 plus tangent squared x equals secant squared x, if I move the tangent to the other side, I now get 1 equals secant squared x minus tangent squared x, which is what I have in my denominator. So now I'm going to replace the denominator with a 1. So let me leave my numerator alone. And now my denominator becomes 1. Anything divided by 1 is itself. So it's just secant x plus tan x. Drop down the right side, and it verifies. We did something similar to this, I think, I think it was sines instead of tangents, but same idea here. What I'm going to do is get a common denominator. So my common denominator is actually going to be both of these. So my first fraction is missing the tangent x plus secant x. And the second fraction is missing the tangent x minus secant x. So my first fraction, when I multiply tangent x plus secant x times 1, it just stays the same. Again, it's got this long denominator. And then the second fraction becomes tangent x minus secant x over the same denominator. Now that I have a common denominator, I can combine my numerator. So my new numerator is tangent x plus secant x, and then plus tangent x minus secant x, and then it all has the common denominator now. Okay, so now, if you recognize the denominator, it's actually, when I FOIL this, it's going to end up being multiplying something by its conjugate. So I'm going to combine my like terms in the numerator. Notice I have 1 tangent x plus 1 tangent x. So this will become 2 tangent x. But the secants, positive secant x minus secant x, that's gone. The denominator I'm going to FOIL. So tangent x times tangent x is tangent squared x. Notice when I do the outside and the inside, it's going to cancel. So all I have to do is the last, and it becomes minus secant squared x. Again, notice it's an identity. So again, the denominator, the identity again I'm going to use is this. 1 plus tangent squared x equals secant squared x. I'm going to rearrange it so it looks like what's in the denominator. I'm going to move secant over. So now I have 1 plus tangent squared x minus secant squared x equals 0. I want it to look like the bottom, so now I move the 1 over. So now my identity looks exactly like the denominator. So now I'm going to replace what's in the denominator with -1. So now I have on the top 2 tangent x, and then I'm replacing the denominator with a -1. Remember what we were trying to get it to equal was -2 tan x. So as soon as I divide that numerator by -1, I get what I was trying to make it equal. So it's verified. So again, you would bring this down and show that it does verify. Now, again, you're just going to have to guess and test. It's going to be trial and error and say, okay, what do I do here? Can I change everything to sines and cosines? No, it's already in that form. I don't have any fractions I'm adding, so I can't do common denominator. So at first glance, I'm thinking, I'm going to multiply by the conjugate. So the conjugate of this is going to be 1 minus sine x. Now, notice on this one, I actually have something in my numerator, so I actually have to FOIL both the top and the bottom. However, the denominator, again, remember when it's the conjugate, all you have to do is first and last, but the numerator I actually have to do the whole thing. So when I FOIL my numerator, I get 1 times 1, and then I'll do 1 times negative sine x, then inside negative sine x, and then last gives me positive sine squared x. So these will be combined. So my new top of my fraction is going to be 1 minus 2 sine x plus sine squared x. My denominator, after I do the first and the last, I get 1 minus sine squared x. Now, notice my denominator, again, when you multiply by a conjugate, your goal is to get an identity. So the blue is an identity. The identity we're using is sine squared x plus cosine squared x equals 1. I'm going to solve it for cosine. So I get cosine squared x equals 1 minus sine squared x. So that's what I'm replacing my denominator with. Let me rewrite my numerator. And now the denominator becomes cosine squared x. Now, if you glance at your right side, notice it's got 3 different terms there. So I'm going to now split up my fraction and make it each have its own denominator of cosine squared x. So I can get 3 separate terms. So I'm going to go ahead and do the 1 over cosine squared x. Then I'll do the middle, and it comes negative 2 sine x over cosine squared x. And then the last, sine squared x over cosine squared x. Now, if you notice, the red and the black actually simplify to what's there. Because the red, the reciprocal of cosine is secant, so I'm going to change the red into secant squared x. And the black, this is tangent squared x. However, the green in the middle, I'm going to actually split that apart so it turns into 2 secant x tan x. So what I'm going to do, again, it's multiplied here. So I'm going to give the negative 2 its own cosine x, and then the sine x its own cosine x. Because if I multiply this back, the cosine times the cosine in the bottom gives me the cosine squared. So now if I simplify it, this becomes my negative 2 secant x, and then this becomes my tangent x. Rewrite the red, rewrite the black. Oops. I needed to change colors. Tangent squared x, this had a plus, and that had a minus. So if you look at your right side, you were trying to make it equal secant squared x minus 2 secant x tan x plus tangent squared x. It worked out. So again, the answer to, if this were a quiz question, would be all of this work. And then showing and verifying that it equals what you were trying to make it start out with. The last example, we're going to find a common denominator. My common denominator is going to be both 1 minus cosine x and 1 plus cosine x. So you can see that the first fraction is missing the 1 plus cosine x. Multiply that to the numerator and the denominator. So over here I'm going to distribute the sine x to the 1 cosine x. Let me just go ahead and write it next to it. So it's going to be sine x, and I'm going to distribute it to the 1 plus cosine x. And then over here, this side is missing the 1 minus cosine x. So over here, I'm going to distribute sine x, cosine x to that. Now my denominator is kind of long, so I'm just going to write it underneath both. So 1 minus cosine x, 1 plus cosine x. Next, I'm going to distribute. So I'll distribute the sine x to the 1 and to the cosine. So sine x plus sine x cosine x. Over here, I'm going to distribute this as a negative sine x cosine x to the 1 first. And then I'm going to also distribute it to the negative cosine x. So it'll become positive sine x cosine squared x. Next, I'm going to look for like terms. So let me rewrite my denominator. I'm actually going to also FOIL the denominator here. So first gives me 1. Notice it's its conjugate. So it's actually going to become 1 minus cosine squared x. Now let me add my like terms in my numerator. These are going to cancel. And then I'm left in the numerator with sine x, and then this blue sine x cosine squared x over the denominator, which is actually an identity. So the identity here, again, is the sine squared x plus cosine squared x equals 1. I'm going to solve for sine x by moving cosine over. So sine squared x equals 1 minus cosine squared x. So that's what I'm going to replace the bottom with. Sine squared x over here. And now for the numerator, I'm going to factor out a greatest common factor of sine x. So sine x is my GCF. Once I divide sine x by sine x, it's 1. And once I divide the blue, I'm left with cosine squared x. And then it still has the same denominator. Now notice the top, I can cancel with the bottom. So I can cancel sine x and sine x. And then I'm left with 1 plus cosine squared x. And only one of the sine x's in the denominator canceled. So I'm left with a sine x in the denominator. So now what I need to do is, if I look back at my right side, I'm trying to get a cosecant in front. So recall that 1 over sine x, which is what I have, is equivalent to cosecant x. So I'm just going to bring the sine x to the top, turn it into cosecant, and then leave the red. And this is what I was trying to make it. This is what I was trying to verify. So cosecant x times 1 plus cosine squared x. It verifies. So again, the answer to a question like this on the quiz would be all of this work. And just make sure that all of your work makes sense logically. So homework for this lesson, which is due Thursday. If you look on Canvas, it says every other odd. Now, if you are looking to do additional practice, you could, to study for the quiz, you could go back and do all of the odds. But the assignment posted on Canvas is every other odd. And that is it for lesson 7-2.